Here we are doing a nozzle and platform level calibration on our H+1 3D printer. With the touchscreen display, we are hitting the calibrate button in the display, and which will walk us through the calibration of the distances that we have. So this is a quick video here showing the reading of the 9 points, and then we're going to be checking the nozzle height. The device we just placed on is a touch probe that will measure a 0.2 millimeter distance between the nozzle and the platform. It'll give a audible beep, and a red light will show as well, so that we know that we are at the proper distance, which is basically the thickness of a business card. Then in the software, the display is going to tell us to increase or decrease the platform height, and once we hear that beep, we hit the check mark and we are set. Now that the auto level is complete, we can now take a reading inside of our Afinia Studio software that the printer is connected to see how our calibration looks. And so if we click the calibrate button here, it is going to give us those 9 points of values. So this point 1 is this point here. So it's our back left hand corner, back right hand corner, front right hand, front left hand. And our values should be in a range of from 0.00 to 0.5 is the acceptable range of distances of the values here. We're always going to have a 0.00. This is front left hand corner. This is going to be the highest point of the platform. That's the sloping up to this point, and then it's going to slope downwards as we move away from here. So we have a 1.32 in our back left hand corner, 1.69 in our back right hand corner. So what this tells us is that we are sloped too far to the back, and these values are outside of that 0.5 or at minimum 1.0, but the best or optimal range is up to 0.5. So so now we're going to go through our process to do some manual leveling to fix this issue. So I'm going to switch to a different view. We're going to go to our webcam. The first thing that we're going to do is we're going to tighten down our screws. We're going to bring down our platform. And this is our platform. Okay, there's our extruder. I'm going to set this back here. These screws here, there's the front left-hand screw, and we have our back right-hand screw is here, and on the opposite side we have the exact same screws. So what we're going to do is we're going to tighten these screws until we've bottomed them out. And you know what? I've been unscrewing the wrong way. Sorry. Lefty-loosey, righty-tighty. So here I am tightening the screw down, and I've got it to bottom out. Okay. Same thing with the back. And we're bottomed out there. And with our front. Oops, once again, righty-tighty, lefty-loosey. Okay, bottomed out. And doing the same with the back. And we're bottomed out. Okay, so now we're going to go ahead and in our software we're going to do an auto level and see what we get back for readings now. And I'm going to switch screens here. Before you do this, before you go to do the auto level, if you've been using your printer, you may have some debris on the end of your nozzle. Whether if you've just finished a print, there might have some drool that may have come off, or you may have some buildup of some burnt on plastic onto the end of the extruder that needs to be cleaned off. The way to do that is before you start your process, you just take your scraper and just on the nozzle, just scrape off the bottom tip, just to make sure that it's fairly clean. And you want to do that before your process starts, so that you get accurate readings throughout the whole, from the beginning of the process to the end of the process. Another thing, as you're doing the auto leveling, if you have just withdrawn your filament, extruded your filament, or just finished printing, if the nozzle's still hot, if it's still above 80 degrees Celsius, the software is going to come back and tell you that it's too hot and that you have to let it cool. And so you just wait for it to get under that 80 degrees Celsius, and then you can go ahead and do your auto level. The reason for that is if the nozzle's too hot, it can damage the surface and some of the and the touch probes that we're going to use in the measuring process. Anytime that you change nozzles, anytime that you change extruders from the ABS to the PLA to the TPU, you should do this process as well to get a new nozzle height level, because the nozzle height from one device won't be the exact same as the nozzle height with the current device. Here we are, system is going through and doing the nozzle detection, nozzle height detection. So it's bringing up the platform until it touches. And the software brings it out to the middle. The next thing we're going to be doing is we're going to be grabbing our touch probe. This touch probe is sensitive in regards to that it if we put pressure here, you'll see that it lights up and beeps. So I'm going to take our touch probe and I'm going to slide it here right underneath the nozzle. And I'm going to show you the software. So in the software, it says please insert the nozzle detection card to calibrate the nozzle height, and then either move up or move down. So here we've got it underneath there. Now if the nozzle was actually touching the platform and you couldn't get the device underneath there, hit move down a few times until you get enough space that you can actually move the touch probe underneath there, and then hit move up until we get a beep. And hopefully you hear that. I'm going to hit move down once, move down again, move up once, and that's pretty good. I'm going to go ahead and click OK, and it's locked in that value. So in here, as we read it now, we're still off, but it might be getting to show us where we need to move. So our 0, 0, 0 is in the front middle, and then we are sloping basically straight back as we move back. So let's show you how to do the manual leveling process. So as we have this now, we know that the front middle is our high point. So I'm going to go ahead and bring the extruder up to that point. And then I'm going to take my probe and I'm going to slide it under there, but I'm too close. I can't get under there. So I'm going to use the move section here. I'm going to hit the down arrow key a few times until I get enough space to be able to slide the probe underneath. And now I can. And I'm going to move it up until I hear a beep. And there's my beep. So now I'm going to copy this value. And then I'm going to move this down a few steps because we want to get rid of that annoying beep. So move the probe out of the way a little bit here. And then I'm going to drive this to, I'm going to start off here in the back left corner. By clicking that button, I can drive the extruder to back to that position. And now I'm going to take my probe and get it placed underneath. I'm going to stand up for this because it's a little hard to see. Just want to make sure my probe is underneath my nozzle. And it is. Then I am going to, that value that I copied, I'm going to paste that in here. And I'm going to click move. Alright, so I've moved it, and of course I'm not going to be setting off that sensor because we know that this back left hand corner is much lower than the front side. So now I'm going to use the screw, and I'm going to do lefty loosey, which is going to bring up the platform, uncompress the spring until we get a beep. Now if I move, it's pretty sensitive here, so if I move a little bit back and forth, I'm going to hear that beep, but sometimes it might go away. So I'm pretty good there. Perfect. And I'm going to go ahead and move this down a little bit again because of, again, that annoying noise. Move my probe out of the way. Drive over to the other back corner. Repeat our process. Probe is underneath there. Paste our value back in. Click move. And we don't hear the beep, so we're going to move our screw. Lefty loosey. Good. Reduce our value here. Move our probe out of the way. And move on to this corner. Try to get our probe under. Now here, can't get the probe quite to go under. So, so before I actually plug the value in, I'm actually going to move this down even more. So this is a righty-tighty. Till I can see some gap in there. Put it in underneath. Now I'm going to paste in a value. And I'm going to click move. It's moved. Now I'm going to go ahead and loosen it back up. And got the value going there. Good. There's the beep going. Going to move to the front left corner. Once again, I can't get underneath there. See if I can just drive this down even a little bit further. Just righty-tighty. Okay, got it underneath. Plug in my value. Paste my value. Ooh, really close. So, there, perfect, good. Move this down a little bit. Now, we've got all these corners hopefully fairly balanced out. So, I'm going to move my platform down to being 100 millimeters off the bottom. Clicking move. Now I'm going to go ahead and do the auto level one more time. And I'm hoping we have improved our platform level. Again, I can't stress enough that this is something that if you do it right from the beginning, it's going to save you potentially a lot of headaches of failed prints, of warping where the raft is peeling up away as it prints, and it can actually peel so much that it'll actually slip off, actually make contact with the nozzle, stick to the nozzle, move around, and then the nozzle just keeps pouring filament, extruded molten filament on top of itself, so it becomes this ball of plastic that can ruin your extruder. The other thing that can be is that if you're out of level so much that you try to compensate for that raft lifting on one side, so you increase the platform height or increase the nozzle height, then what can happen is if you've got a high area over in like the front right corner here, now that's going to be even closer to the nozzle. It's going to cause some back pressure, or the nozzle might even drag against the platform, and when you do that, it'll cause back pressure into the extruder. You'll hear clicking when the filaments are actually trying to be driven through the extruder. The gear will be clicking against there, and it will clog the extruder, and you'll be air printing. It'll just move the extruder, nothing will come out, and you won't have a print, and you have to clean out the extruder then at that point. So making sure that your platform is level, you have good nozzle height, is going to help prevent those. about 90% of the issues that we have with customers with failed prints is because of this process. One other thing I'll say is, and I probably already mentioned it, but don't take the model off of the platform after you finish printing while the platform is still in the system. Actually remove it, so you pull the platform straight out, and then you can place in a new platform, or take off the model, clean off the platform, put it back in, and start your next print. So now go ahead and our software is asking us to put this back in. And asking us to move up. And we have the beep. I'm going to move down once, move down again, move up once. Okay, so we're good. We're good in that range. So now let's take a look at our values. And holy buckets. If we just if we didn't do good, I don't know what we did. But we take a look at our values now. Now our 0 point, we have 2 zeros here. We got the back, middle, and we have our center is at 0. And our largest value is a 0.2. This, ladies and gentlemen, this is dead nuts on. This is where you want to be. Okay, so from this point we go ahead and we click confirm because we are happy with that. So that is one level platform. You're going to get some really successful prints off of there. So let's go on to the next step here, and let's talk about the platform. Remember, I said don't take off the model while it's on the platform, because you're going to be pushing down. You're going to drive the screws. You're going to drive the springs. You're going to take all of our hard work that we just did and screw it up, because you're going to drive this thing out of level. So when you remove the platform, just simply pull it straight back. Okay. Now we've got a couple of different platforms here. I'm going to show you. And I'm going to show you what to do for maintenance on these things. When you get the print off, let it cool a little bit. That'll help with removal. But once it's cooled down for a couple of minutes, then you'll take your scraper, okay, and come off to the side of the raft, and you're going to come underneath, with a flat angle, get under, pry up, pry up, pry up, to get the model off. Okay. That's on our. This is our perforated glass board. This is the flex surface glass board. We'll talk about the flex surface here first. This one is a good universal type of surface for printing, good for PLA, PGG, ABS, and such. And what happens is that this surface, when it heats up, it wants to lock onto the plastic and hold it down into place. And then once it cools down, it'll start to release the plastic. And then, like I said before, do a flat angle when you're scraping underneath the raft to pull that up. If you come down at too steep of an angle and you're pushing, into it, there's a good chance you could slice the surface. Once it's sliced, its days are nearing to be done. You can get new surfaces. They're called Build Tack. They're on our website. Otherwise, you can get new of these flex glass boards on our store site as well. But if you maintain this well and you treat it well, it'll last you for at least 100 prints, and if not more than that. Now, nozzle height is very important. If your nozzle's too close, you can actually start to impregnate some of the the plastic into the surface itself, make it very difficult to remove. So that process we just did should allow us to print really well on any surface. So this surface here is our perforated surface. As you can see, there's lots of little holes here. This one's great for ABS, polycarbonate, materials that want to contract when they cool, causing warping or a rocking chair effect. And these little holes here will fill up with the plastic as it prints and act like little spikes from a soccer cleat to hold it down. Now don't worry if you've used this multiple times and these holes start to fill in all over. These holes, as they warm up and heat up and the other hot plastic goes onto them, they'll bond right to that plastic just like it's its own, and create that cleating action still. So but now let's talk about the glass surface here. Both of these have a glass surface, and the glass surface is good for PLA especially, and PETG. Again, those materials that are non-warping or less likely to warp. What you'll use is just a regular Elmer's glue stick, the purple glue stick, or other glue sticks, and then you just rub it on. This one's got some glue stick on it already. You can actually print a few times on one surface. You just want to make sure you get enough glue stick around to where the model's actually going to be printing onto. And then let's talk about maintenance here. Is anytime, this could be an everyday type of thing, or every print, or whenever you feel that it's not sticking too well, or you're getting too much lift or too much warping, is I'm going to set this down for a second. Is you want to use some isopropyl alcohol to clean the surface, whether you're using it in a little moist towelette and wiping it down, or if you got you can put it in a little squirt bottle like I have, squirt a little on and just take a paper towel and wipe it down. Now with the isopropyl alcohol, it's just a very, very light solvent, and what it'll do is, besides cleaning up any debris, it's also going to take off any of those little oils that come off of our hands. This is the fingerprints and everything that we put on. That causes that lubrication of the surface and causes peeling or non-sticking type of issues. So we've went over a lot, and folks, I really appreciate your patience. This is really important stuff. I hope you found it useful. This is contact information for you if you have any questions afterwards. But thank you for your attention, and good luck with your 3D printing.